Yes, hello, thank you for having me here and giving me this amazing opportunity to talk about my PhD project to this broad audience of people knowledge in microglia and neuroinflammation. And my work is done in a mouse model in the field of Parkinson's disease. Here on the left-hand side, you see this typical posture that shows the motor symptoms, but I will focus more on the background in the pathology that we see in patient and also animal models, the formation of Lewy bodies that are positive for alpha-Synuclein. And my project also focused more on the early stage of the disease where you don't really recognize the patients as patients, where they don't have any symptoms. But in this first stage where we have a risk to accumulate, to develop Parkinson's disease later in your life. And one part of this risk might be a systemic infection that you encountered. I think we previously heard some things about lipopolysaccharide and Parkinson's disease. And I want to focus on this molecule as part of gram-negative bacteria because there are studies that show that Parkinson's disease patients have an elevation of gram-negative bacteria in the gut microbiome and therefore most likely are exposed to a higher dosage of this LPS. And this pathology that then is in their gut might travel somehow to the brain to lead to an hypothesis that says that the disease state, that the accumulation of alpha-synuclein in the brain is not derived originally from the brain, but might also develop somewhere in the periphery like the brain, like the gut, not the brain, and then travel to the brain. And therefore more than one factor is responsible for development of the disease, so not just environmental factors, but also genetic predisposition and so on. To investigate whether a mild gastrointestinal infection can already impact brain pathology in synaptopathies, I'm working with a mouse model that overexpresses alpha-synuclein to model the disease that is seen in the human. And we inject intraperitonially this animal with a very low dose of LPS to not put a high burden on the animal, but more simulate like a mild systemic infection. And then we want to look whether this is already enough to see some neuroinflammation. We have different groups because, of course, we're not only using our animal model, but we also use wild-type littermates as a control. And therefore, we then look whether the LPS injection has an influence on PD symptomatic and the pathology in the form of focusing on behavior and the brain histology. We're doing this not at one time point, but my project is focused on a time scale where we have early time points and later time points to see whether this is really something that is developing, because of course Parkinson's disease is a developing disease, so different time points might reveal different things going on. First, to focus on the early time point after 3 and 7 days. First, I started off with looking at microglia, of course, to look into neuroinflammation. And here on the side, you can definitely see a difference. So yes, LPS is doing something to the brain, even if you just inject it intraperitonially. And looking into the data further, you can see that in some parts of the brain, like the rostral hippocampus, even low dosages of 0.3 mg per kg and a bit higher dosages of 0.8 mg per kg of LPS are enough to really induce in wild-type and transgenic animals a microgliosis in the brain. Other brain regions seem to be not as susceptible to this neuroinflammation. There we need a higher dosage of 0.8, that's still quite low, because other people use up to 5 or 10 mg per kg. But also just then the transgenic animal is affected by this. So there seems to be some interaction of the LPS given and their predisposition with the alpha-synuclein that's in the brain. Interestingly, this is not an overt effect, so not through the whole brain, but we also detected some brain regions where we see less microglia. So this is something we need to look further into. Why are certain brain regions more affected? Why do these brain regions react like that? So at 7 days, we had this microgliosis going on. So of course, we also looked further earlier. And at 3 days, interestingly, we had no microgliosis yet. So this seems really to be something that develops with time. So not something right after the LPS, but something that, develops. To further look into this early time point, we also did FACS of the brain, so flow cytometry, together with our cooperation partner. And also there, over the whole brain, we couldn't detect any real changes in the total amount of microglia that we found. But looking into certain markers, the MHC molecules, we saw something we expected, so an upregulation of MHC class 1 that is often seen after inflammation, but also a downregulation of MHC class 2 proteins on the microglia. This is something we definitely need to look further into, because we didn't expect it. Normally, we would more expect an upregulation of this. Now I want to take you a bit further away from maybe the topic you're more familiar with, because in the later time points, I mainly focused for now on behavior, and will later look into the things that happen in the brain and then relate this together. And one of the tests I performed was the challenging beam test. To those who are not familiar with this testing, you have a narrowing beam where the mice run over, and you have a mesh on top, and as you can see here, if a paw of the mouse passes through the mesh, it's an error, because a normal ability mice should be able to pass this mesh without a mistake. And there we could interestingly see 2 weeks roughly after the LPS injection that after a few trials, when the mouse are more tired, it seems like the LPS already has an effect on the motoric behavior of the mice. So even this low dose of 0.8 mg per kg of LPS in the transgenic leads to a worsening of the motor symptoms. In parallel, we looked at a 2-month time point also at the cognitive behavior in the form of the Y maze. And we looked into indirect revisits, so if the animal goes not in a circle, like circling through all arms, but goes to one arm and then back to the previous one. And there we also seem to have a slight effect that the transgenic animals treated with LPS make more of these mistakes, so they also seem to have at a 2 months time point kind of a cognitive impairment. So really this low dose of LPS seems to do something that, shows an exacerbation of symptoms. So to sum this up a bit, does a mild gastrointestinal infection impact brain pathology and synaptopathies? We saw at 3 days not yet a microgliosis, but a change in the proteins on top of microglia, so there already seems to be something going on. At 7 days then, we really have in different brain regions a microgliosis that depends on the LPS that is given, and also on the genotype behind it, so there seems to be some kind of interaction. And looking into the behavior, we see an exacerbation of motor symptoms that just exist on the interaction of the LPS with the transgenic genotype, as well as the slight cognitive impairment. So yes, there seems to be reasonable evidence that even this mild infection is enough to trigger some neuroinflammation in the brain. Going on, of course, I also want to look how this microgliosis is processing. Is this just something coming up around 7 days and then dying down again? Or as the motor and cognitive impairment implies, something is taken further and not just repaired. And also we have a very old cohort planned where we want to look not only into microglia, but of course also the alpha-Synuclein and other neuronal markers to also detect whether there's neurodegeneration exacerbated. And for the Y maze, we also plan on filling up the groups to further put more weight on this. And with this, I want to thank my lab and our cooperation partner of the Twin Core in Hanover, and the people from the Center of System Neuroscience in Hanover. That's where I'm doing my PhD in. Thank you.
Thank you for presentation. Please, time for questions. Please.
Thank you for this nice presentation. I was just wondering if alongside the microgliosis you also explored or are planning to explore different cytokine levels and biomarkers and things like this over time in the brain?
Yes, definitely. So we took the blood from all the mice, the groups that we already did, so to also look what's going on in the blood, but we also plan maybe further groups to look into more in the brain. We also look into other immune cells in the brain, but of course there's not that much going on then with microglia that are already there. But yes, definitely an important point to not look at the cells. Just
The ongoing work, is that right?
Yes,
Okay.
I'm not finished.
Thank you.
Okay, please. Okay.
Thanks, that was great work. I mean, this goes a bit beyond your PhD, but mice already have quite high levels of LPS in their blood relative to humans, and it would be cool to try and reduce levels of LPS rather than increasing them to see whether you could decrease symptoms in alpha-Synuclein expressing mice, for example, by modifying the microbiome of the gut or a variety of other.
Yeah, that's an interesting point. We already thought about a project to see how pathogen-free environment and so on is working. Unfortunately, I think our animal facilities are not clean enough to really do it in-house. So that's something that we plan to also to look how changes of the gut microbiome has an influence. But I think we at the moment not yet the right lab to do this, but maybe in the future. But yeah, definitely a good point.
Yeah, some nice work. I have two questions. Do you know if this 0.8 mg per kg is enough to induce training in your microglia? Have you checked?
No, we didn't. We just looked at this one-time challenge because we wanted to keep it more close to a patient that might suffer from a disease that's just like a stomach bug or something, and not something that's often. But we also plan to look into a more chronic stage where we induce more chronic colitis and look what is that doing. So that might be closer to a training.
No. So what I mean is, do you induce tolerance with 0.8, or does that induce sensitization of your cells? Do you have any idea?
Not really.
Okay.
So.
And at the end stage, do you know, is there an effect on the amount of alpha-syn in the brains of these animals after in the LPS cohort?
I think it's going to. Also, we have aged animals that are several months after the injection, 7 months after the application, I think. And a first glance at the data told me that yes, there might be more alpha-Synuclein, but we don't have enough animals yet to really put weight on this. But yes, it might influence the alpha-Synuclein. But definitely something I want to look further into. Because
Okay, I don't see any more hands raised. Therefore, thank you. And we also thank all the speakers of today. And also we thank Neuronal Signaling, who sponsored this session. Thanks to them. Okay.